This is Ranjit. Today we are discussing C programs, a perfect number program in C language. What is a perfect number? A perfect number is a number which is a positive number, and when the sum of its divisors if you equal to the same number, then it is called as perfect number. So what is a perfect number? A positive integer which is equals to the sum of its proper positive divisors. So please sum the factors. If you get the same number excluding its own, then it is called as perfect number. Let us see an example. So in this example, these are the perfect numbers where find out the factors for these numbers. If you sum it, you will get the same numbers. Let's get into detail. So if you take a number 6, the factors are 1, 2, and 3. If you sum up, you are getting 6. So 6 is a perfect number. If you take 28, the factors are 1, 2, 4, 7, 14. Then 28 is a perfect number. Whereas, so this is a way of doing a program of perfect number. Find out the factors of 28, which are 1, 2, 4, 7, 14, and 28. Exclude itself and add all. If you compare sum and the original number, sum of factors and original number, then that number is perfect number. Now let us write a program, C program, to find out a perfect number. Okay, so here we are starting with the basic live programming. Okay, so here we are declaring an integer variable. Okay, so we are accepting a number, printf, enter a number. Of course, enter a positive number. We'll accept a positive number because a perfect number is a positive number. So scanf percentile d ampersand a of n. So percentile d and comma a of n. So we will take num. So we have accepted the step 1. So we declared a variable and accepted number. Now let us find out the factors. So how to find out the factors we have discussed in the previous video, which is factorial of a given number. So you can also see the factors program in the other tab, where this is a procedure to find out the list of factors and getting printed. The only difference is if you sum all those factors, it is called as perfect number. It is equals to the same number. Now let us start writing. The initialize sum is equals to 0. Then start finding out the factors from 1 to num by 2. So we'll discuss why we are taking num by 2. Okay. So if number modulus I double equal to 0, this condition is true means what? The num is what? Num is perfectly divisible by I. So I is a factor and I is a factor of num. So let us add all those factors. Sum is equal to sum plus I. Be clear? So once you come out of the program, let us compare the number what you have accepted and sum. If both are equal, then the number is perfect number. Printf perfect. Be clear? So else not a perfect. So which is not a perfect number also we can print using not a perfect number. Okay, so we can also print what are the different factors we have added using simple printf statement. This is an extra statement only to prove which number is getting added. Okay, so printf. Okay, so is divisible by Okay, so we are printing the. Okay, so now if you observe, here we finish the perfect number program. Now let us compile the program. To compile, we are saving the program with the perfect number dot c. Okay, so let us compile the program. And, please try to close the for loop. Okay, so here we close the for loop. So we are corrected all the errors. Now let us see the output. Now enter a number. If it is a 6, then it is a perfect number. So in the printf, if you write this num and I, you can get the correct output. So 6 is divisible by 1, so adding to sum, 6 is divisible by 2, adding to sum, and 6 is, why not a perfect number? It is a perfect number. So we have to consider less than or equal to num by 2 because, okay, so let us consider, and 6 is divisible by perfect number. Are we clear? So this is what a perfect number. Okay, so hope you have understood. Now let us explain why are we taking this n by 2. So if you observe here any perfect number, the all the factors are available in first half of the number only. In the second half, there is only factor which is itself. So all the factors will be available in the first half of a given number. If you take another example in 28 also, 1, 2, 4, 7, 14, all the factors are available in the first half. So anyway, we don't want to consider the number which is itself. So, so it will improve the program performance by reducing the number of iterations. So that's why we are taking num less than or equal to I less than or equal to num by 2. So we can take I less than n num. Better to take num by 2, which will improve the performance. Now let us compile once again and run the program. So 6 is divisible by 2. So adding to sum 1, 3, 6. So both are equal. Then it is a perfect number. Let us see one more example. 28. 28 is a perfect number finally. So this printf is only to show what is happening in the program. It is not compulsory. Okay. So we are just printing the values. That's it. So this is not required. This is only to show what is happening in the program. Okay. So you can print whatever you want. Okay, so let us print once again 28. The factors are 1, 2, 4, 7, 14. If you sum, then it is a perfect number. Are we clear? So if you see 28, 28 is a perfect number. So we are adding only factors, okay, excluding its own number. This is perfect number program. Okay. So can we print the range of perfect number between 1 to n? Yes, we can print the range of it 1 to n. Let us write the same program once again. The only difference is we are accepting a range. Okay. So enter a range to which perfect number is to be calculated. So what you will do is you will write one more loop here. For I let us take number is equals to 1, num less than or equal to n, and num less. So we want to include number, so less than or equal. Okay. So what is happening here? We are checking each and every number whether it is perfect number or not. So we don't want to print this not a perfect number here. We are just printing the list of perfect numbers. Okay. So printing perfect numbers. So printing perfect numbers. Clear? So let's close in a double quotation. So perfect numbers, range of perfect numbers are that 1, 2. Let's compile the program. Is range of perfect numbers dot p. You try to compare, declare all the variables. So always errors will be declaring a variable and lower brackets and semicolons. If you correct the basic errors, it will be easy to compile the program. Okay. So sum is equals to 0. So enter the range. Now assume that I want to find out the list of perfect numbers, which are 1 to n. Okay. So we don't need to print the list of perfect factors here because we are finding out a range. Okay. So if you enter 100, the perfect numbers are 6 and 8 between 1 to 100. If we enter 1000, the range of perfect numbers are 3. So 1 to 100, there are two perfect numbers. 1 to 10, there is one perfect number. 1 to 1000, there are three perfect numbers. If you compile once again, 1 to 10,000, there are only four perfect numbers. So as the digit increases, the number of perfect numbers is increase. So this is a program to demonstrate a perfect number. So hope you have understood how to calculate the perfect number, and this is an important program. So, so thank you so much for listening to class. See you in the next lecture where we learn another program. Thank you so much. See you and keep practicing the programs. Please type the program live and so that you can understand different errors and different. Thank you.